This video is going to cover a few of the problems that you have on these notes, number 4, 5, and 6. Make sure that you do copy everything if you don't have access to the actual worksheet. I know it's a lot, but you can just pause the video if you need more time. All right, so here for number 4, we have that suppose f of x is equal to x squared plus 2x plus 7. So we have this function right here, okay? We want to evaluate when f of x is equal to, when x is equal to 6, okay, meaning this part right here. And the way to do that is pretty much just to replace every single x with whatever is inside the parentheses. And you've done this before, okay? So we're going to go ahead and do that for this first example right here. I'm going to go ahead and instead of doing my x squared, I'm going to do parentheses square plus 2 times, instead of x, I'm going to put a parentheses plus 7. So basically wherever I have a parentheses is where I had the x. Where I have these x's, okay? So I'm going to replace that with, in this case, the number 6. And I'm just going to evaluate this by using PEMDAS, the order of operations, to come out with a single number. So we're going to do that by starting off with our parentheses, and that would be, let's see, we have 2 sets of parentheses, but there's really nothing going on inside them except for the whole number. So we move on to exponents, which would be this 2 right here. So 6 squared, remember that 6 squared is the same as 6 times 6. It's going to give us 36, okay? After exponentials, we have multiplication and division. So we do have a multiplication going on right here. Remember, this is the distributive property. So 2 times 6 is 12, positive 12. So I'm going to go ahead and bring that down. And that pretty much is all we have to do because there's no other operation to do. So I'm just going to bring down that 7. And now I'm left with a simple addition problem. Okay, so I would just go ahead and add this up right here. So let's see, 36 plus 12 is going to give us 48. And 48 plus 7 is going to give us, get a different color for the answer. So 48 plus 7 is going to give us, let's see, 7 plus 8 is 15, carry the 1, 55. However you want to add this up. Okay, so that means that f of 6 is equal to 55. Another way to think about that is if I were to graph this point, when x is equal to 6, y is equal to 55. So it's just some different ways of seeing what this actually means, okay? The next part says that we would evaluate f of p. So now I have a p by replacing x with p wherever x appears, okay? And pretty much it's the same thing, except instead of x, we're going to put a p now. So I'm going to go ahead and put those parentheses again. So I have parentheses squared plus 2 times parentheses plus 7. And I'm going to go ahead and put a p inside. So this letter p here. And since p is just a variable, just like x, there's really nothing else we can do here because we really can't combine any like terms since p squared and 2p are completely different terms. So we can leave it like this, or we can take away the parentheses. I'm just going to go ahead and leave it because in this case, it is the same thing. Okay, and last but not least, we do have a more difficult problem. So let's go ahead and look at that. This one is x plus 2. So x plus 2 is now going to replace, again, everywhere you see an x. Now, some people get confused because they say, well, we already have an x there. Well, yes, but this entire term, x plus 2, is now going to replace the one x that we had here. Okay, so let's go ahead and see. We're going to have a parenthesis squared, so that's this first one right here, plus 2 parentheses, that's this one right here, plus 7. And I'm just going to take that x plus 2 and put it inside. So x plus 2, x plus 2. Okay, now this one gets a little bit tricky because we do have that x plus 2 squared. So what I'm going to do is I'm going to go ahead and scroll over onto the right side of my page and show you how to do that right here. So we're looking at this side of the page now. Okay, I'm going to scroll a little bit and then we'll come back to this. So this says show that f of x plus 2 is equal to all of this. So what we're going to do first is we're going to calculate that x plus 2 squared, because remember, that's what replaced this part right here. That's this piece right here. Okay, so to do that, I'm going to go ahead and expand this. So x plus 2 squared, this little 2 means that there's two of them. So that means I have an x plus 2 here and an x plus 2 here. And we're just going to use something called FOIL. Okay. Now, FOIL does not mean we're going to have x times x is x squared and 2 times 2 is 4, and that's it. We have to go through the motions. So we're going to do this one kind of quickly. We have first, which is the first term times the first term. So that's our f. X times x is x squared. Okay. And then we have the outer. So we're going to look at x times 2. So this is our outer. X times 2 is 2x. And it's positive because that's a positive 2x. I'm sorry, it's a positive 2. And then we have the I for inner. So this is our I. And that's also going to be plus 2x. Okay. And last but not least, we have L, which is the last one. So this one right here, L. 2 times 2 is 4. And then from here, we just combine like terms. So x squared stays the same. These two go together. 2x plus 2x is 4x. And then we bring down that 4. Okay, so this entire piece is just this part right here. Okay, notice that the answer is all this. So we're not quite there yet. Okay, so I'm going to scroll back a little bit now over here. And so this entire piece is what I did right here. So now I have x squared plus 2x plus 4. And I'm going to bring down everything else. Plus 2 times x plus 2. So I'm just bringing all this down. Okay, plus 7. And we're going to distribute next. So I would go ahead and do this piece right here. 2 times x is 2x, positive. 2 times 2 is 4. Okay, hopefully I'm not getting too messy here with my work. Bring down the 7. Bring down all this, so x squared plus 2x plus 4. Okay, I'm going to scroll down just a little bit. And we're going to combine all like terms at this point. So once we get to this point right here, okay, I can combine like terms. So it looks like I only have one x squared. So that one is taken care of. And then I have a 2x here, a 2x here. Let's see. So it looks like, oh, I made a mistake. Make sure you correct that. This was not 2x. This was 4x. This was 4x. So make sure you make that correction, okay, before you mess things up here. So we have 4x, okay, plus 2x, and 4 plus 2 is 6. And then finally we have the 4, and the 7. So 4 plus 4 is going to give us 8, plus 7 is 15. And that is exactly what I have over here. Okay, so that's a little bit of function notation for you here and how to work it out. We're going to go ahead and do the last two problems. These have a little bit more to do with word problems and how to interpret these. So number 5, again, make sure you do copy everything down. Number 5 says to go ahead and use everyday language to explain what each of these situations mean. So let's look at the first part. It says, let C of T be the number of people in millions who own cell phones. So this part, this is the people who own cell phones in millions. Okay. T years after 1990. So so many years after the year 1990. What do each of these mean? So if I remember right, I think I might have given you some of these for the Nearpod. So I'm going to go ahead and make sure I don't do those. So I'm not going to do, I want to say it's this one. I'm not going to do B. And then for the next problem, actually, I'm not going to do B or C because I don't remember which one I did for you guys. So you'll have to do those on your own, okay? Same thing with this one. You will do those on your own. But let's look at letter A. So it says C of 10 is equal to 100.3. Okay. Well, T it represents is noted right here. Okay. So T represents the years. So this is saying that after 10 years, okay, 10 years after 1990 to be more specific, there was 100.3 million people who own cell phones. So we can write that a couple ways. I'm going to go ahead and just write it one way. You can write it as long as it gives the same idea, it's fine. Okay, so I'm going to say that this is the number of people, okay, with cell phones 10 years after 1990, 1990 was 100.3 million. Okay, so something along those lines works for letter A. I'm going to skip down to letter D and see how that one looks. We have m is equal to c and then t plus 10. Okay, so this one's a little bit more confusing. Remember that c is equal to, c of this is the number of people in millions who own this after this many years. So this would be, m would be equal to this exact same thing in terms of c of t. So let me write this and then I'll try to explain it. We can say that m, okay, million people had cell phones, okay, t plus 10 years after 1990. Okay, so since C of t is exactly this, the number of people who own cell phones this many years after that, m is equal to that. So therefore, m million people is equal to this. But in this case, it's not C of t, it's 10 plus t because we're defining t to be equal to t plus 10. Okay, hopefully I said that right. That T and that 10 kind of gave me a tongue twister there. But yeah, that's basically it. Okay, we're gonna do one more and then you have to do the rest by yourself. Okay, so number 6, we have, again, go ahead and copy. You put a raw room temperature yam in a hot oven. Okay, let y of t be the temperature in Fahrenheit degrees of the yam t minutes after you place it in the oven. So y of t, after 45 minutes, you take the yam out of the oven to let it cool. Okay, so it's the same thing. What do each of these, what could they represent? Okay, well, letter A says y sub 0 is equal to 75. So remember that this right here is t. So t is equal to 0 here. Okay, so that means when the time hasn't even started, okay, the temperature is already at 75, kind of like our initial value, because that's what this is representing. Okay, so we can put that something along those lines. So we can say at time of 0, or you can even say t equals 0. Okay, the temperature, and I'm going to write this a little bit shorter because of the space, was 75 degrees Fahrenheit. I'm gonna leave it like that. Okay, so something simple along those lines works. Okay, now I'm gonna go ahead and do letter. I guess I'll do one of these. Hopefully, I don't do the one that I gave you as an assignment. But if I do, that's okay. You can do the other one. So let's do letter. Let's do letter B. Letter C looks kind of easy. So this one, remember, this is T. Okay, so this means that the temperature when time is equal to 5 is less than the temperature is when time is at equal to 10. So we can write that in some way as well. We can say that the yam's temperature, and I keep forgetting to mention the yam, but the yam's temperature, okay, after 10 minutes, and I am I'm not writing the whole word because of the time here. Okay, is greater. So I'm kind of going backwards here. We're saying at 10 minutes, it's greater than when it was at 5 minutes. Is greater than the yam's temperature after 5 minutes. And of course, you can do it the other way around. Say that the yam temperature after 5 minutes is less than the yam's temperature after 10 minutes. Okay, let's go ahead and move on. So letter B is similar to letter D, so you can probably do that one by yourself. And we're going to look at letter E, just because letter E is a little bit different. Actually, maybe I should give this an extra credit. I'm going to give you a hint for letter E. Okay, so I expect to see this in your notes. Hint. This looks similar to this. These are y's, okay? Okay. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is a formula that you should hopefully remember, okay? And if you can remember what formula it is, you can remember what it stands for, that will give you the hint on how to find this one. So I'm curious to see if we can figure this one out. Okay, but yeah, that's pretty much it for this video, guys. If you have any questions, as always, just log in, let us know, and we'll help you out.